So, good morning dear student. Today again I will continue this increasing and decreasing function. So, here I will solve some more questions and then you will get more ideas. So, we are actually doing exercise 6.2. Now in exercise 6.2, so there are some other very important question. That type of question I am going to show you today. It is given question number 6, exercise 6.2. 6, question E. It is given, find the interval in which the following functions are strictly increasing or strictly decreasing. The function is given actually x plus 1 whole cube, then x minus 3 whole cube. So here we will give this name, let y equal to x plus 1 whole cube into x minus 3 whole cube. Then we are going to differentiate it, dy dx, because the first derivative test we have to do. So differentiating with respect to x, differentiating with respect to x. So this side will be dy dx and this side it is u into v. So u ddx of v. This is x, suppose x cube. So 3 into x minus 3 whole square. ddx of x cube is 3x square, but it is not x. So again ddx of x minus 3 will be ddx of x1, 0. So that is 1. Plus then v. v is x minus 3 whole cube into ddx of u. This is u. So this u actually it is v. So x cube. This suppose is x cube again. 3x plus 1 whole square, but it is not x, again ddx of x plus 1 will be into 1. So now I got actually this is dy dx 3 into x plus 1 whole cube, then x minus 3 whole square plus 3 into x minus 3 whole square, whole cube, and then x plus 1 whole square. Now what is common? See, here it will be 3x plus 1 whole cube, x plus 1 whole square. So x plus 1 whole square is common, and x minus 3 whole square, x minus 3 whole cube. So x minus 3 whole square is common. So this is 3. Now here it will be x plus 1 one time plus here x minus 3 one time. So that is we got here 3 into x plus 1 whole square into x minus 3 whole square, and this will be x plus x twice x, 1 minus 3 minus 2. So that is, if I take from here 2 common, so 2 3s are 6, x plus 1 whole square, x minus 3 whole cube, and 2 is common, it will be x minus 1. It is dy dx. Now see, so strictly increasing means you have to remember dy dx should be greater than 0 and we have to find the interval, and strictly decreasing means dy dx less than 0 and we have to find the interval. Under what interval dy dx less than 0 and on what interval dy dx greater than 0. So now see, first of all I will find here the critical points. Critical point means, suppose if I will write dy dx 0, so therefore from here it will be like 6 into x plus 1 whole square, then x minus 3 whole cube, this is not whole cube, okay, it is actually whole square because we have written here whole square, sorry, it is whole square. So x minus 3 whole square and then x minus 1 is equal to 0. So now see, if I write this equal to 0, therefore 6 is not 0, either this 0, this 0 or this 0. If this equal to 0, so x equal to minus 1. If this 0, x equal to 3, and if this 0, x equal to 1. These are the critical point. So if I put this, all the things on the number line, it is minus infinity to plus infinity. So minus 1 is here, then plus 1 is here, then plus 3 is here. So these three values, minus 1, plus 1 and 3, divide the interval in 3 parts, minus infinity to minus 1, minus 1 to 1, 1 to 3, 3 to 4, 4 parts. This is 1, 2, 3, 4 part. Now we have to check in which interval dy dx greater than 0 and in which interval dy dx less than 0. Let's see one by one. I'll show you here. Suppose I have taken one value in this interval, suppose minus 1 to minus infinity. So one value I will get x equal to minus 2. So if I put here x equal to minus 2, let's see what is going to happen. This part will be always positive because whole square is there. Anything whole square will be positive value. It may be 0 and always positive. So no need to check here actually. Now see here. If I put minus 2x, minus 2, minus 1, it will be minus 3. So ultimately this side will be minus. So all the thing will be less than 0. Here it will be minus. Then in this interval minus 1 to plus 1. So here you don't follow that minus plus alternate sign because there are 3 terms, 1, 2, 3. So now in this interval we are going to check minus 1 to plus 1. Suppose the value is 0. So if I put x equal to 0, this is positive, positive, but this will be again negative. So again in this interval negative. Now take one value here, 1 to 3, suppose 2. If I put x equal to 2 here, put here x2, this is always positive, 2 minus 1 plus. So plus, whole thing is plus. So here is again plus, 3 to infinity. If you take 4, this is plus plus, it will be also plus plus. So therefore you can say, see, on this interval minus minus, that is here it is strictly decreasing, and plus plus here it is strictly increasing. So therefore we can say, therefore the function is strictly increasing in the interval (1 to 3) open interval, because you cannot take 1. If you take 1 equal 1, then this part will be 0. Then dy dx equal to 0, but strictly increasing means dy dx only greater than 0. So therefore 1 to 3 open interval and then 3 to infinity. Obviously 3 is also open because if I put x3, the entire thing will be 0 and infinity is always open. So here it is strictly increasing, and then say here in these two cases, and the function is strictly decreasing in the interval, that is minus infinity to minus 1 and minus 1 to 1, not including minus 1, because if I take minus 1, this part will be 0, minus 1 plus 1 will be 0, entire thing will be 0. Then 1 is also not included. If I take x equal to 1, this part will be 0, whole thing will be 0. So here it is decreasing, here it is increasing. So this is question number 6e. Now question number 7. Come to question number 7. Let's see. This question number 7 is asking, show that y equal to given log of 1 plus x minus twice x by 2 plus x. Here it is given x greater than minus 1. This is actually the condition is given. Is an increasing function of x throughout its domain. This is actually its domain, x greater than greater than minus 1. So x greater than minus 1 means my interval will be now minus 1 to plus infinity. That is from open interval, it is minus 1 is not included. After minus 1 to less than infinity, in this interval I have to show this dy dx is greater than equal to 0. It is saying only increasing. So therefore equal sign will be also there. So now we have to find first here dy dx. So dy dx you do. So differentiating with respect to x, dy by dx equal to log, this is suppose x, 1 by 1 plus x. Again ddx of 1 plus x is 1, no need to write. This is u by v. V square, then v ddx of twice x is 2 minus u twice x ddx of 2 plus x. 2 plus x is 1. So therefore ultimately we will get here, this is multiply 4 plus 2x minus 2x divided by 2 plus x whole square. This is cancelled. So it will be 1 by 1 plus x minus 4 by 2 plus x whole square. Now take the LCM. It will be 1 plus x, then 2 plus x whole square LCM. So this is cross multiply like 2 plus x whole square minus 4 into 1 plus x. So it is 1 plus x into 2 plus x whole square, then a plus b whole square, a square 4 plus twice ab, 4x plus x square, and here minus 4 minus 4x. Now see this minus 4 plus 4 cancel, plus 4x minus 4x cancel. So ultimately dy by dx I got equal to x square by 1 plus x 2 plus x whole square. Now see, if I write here dy dx 0, dy dx equal to 0, equal to means this whole thing equal to 0, x square by 1 plus x then 2 plus x whole square is equal to 0. So if I cross multiply, then what I get here, if I cross multiply means x square equal to then 0. X square equal to 0. So x square equal to 0 means x equal to 0. So my domain is given minus 1 to infinity, because it is given x greater than minus 1. So my interval is only minus 1 to infinity. Within this interval, another one when I got x equal to 0. So I have to show in the whole interval, minus 1 to 0, 0 to infinity, dy dx, this is always greater than equal to what? 0. That is called increasing. It is not given strictly increasing, that's why equal sign will be there. Now you see, if I say in this interval, you have to use this one now. In this interval, minus 1 to 0, if I put any value here, minus infinity to 0, suppose it is, you can say, minus 0.5, minus 0.5. If I put here, let's see, 1 plus minus 0.5, that is 1 minus 0.5, it will be positive. So it will be positive, your whole square is there positive, and this is x square, it will be also positive. So everything will be positive, plus. Then here you see 0 to infinity, 0 to infinity. 0 to infinity, if you take any value, suppose 1, 2, 3, 4. If I take 1, plus, here also plus, all will be plus. Here is also what? Plus. So therefore in this entire interval, divided, only when x equal to 0, if I take x equal to 0, then this will be 0. This will be never 0, plus 1 plus 0 is 1, 2 plus 0 is 2 square 5. This will be never 0, only this will be 0, so 0 by something, answer will be what? 0. Therefore 0 is also included. So therefore we can say, therefore fx is, y is increasing, you can say, because y is given. So therefore y is increasing in the whole interval, in the given interval, or in the domain set, you can say, in the given interval, minus 1 to infinity, or you can say throughout the domain. Question number 8 you can try by your own. That is a very easy question. Now you see question number 9. That is trigonometric function is there. That is another one important question. So that one I am going to show you now. So question number 9 is given that a y equal to given 4 sin theta divided by 2 plus cos theta minus theta is an increasing function in the interval 0 to pi by 2. In 0 to 90, I have to show dy by, here it is theta, dy by d theta is greater than equal to 0. Because it is again increasing, so equal sign will be there. So first of all, we are going to differentiate it. Differentiating with respect to theta. So it will be dy by d theta equal to this u by v 2 plus cos theta v square v 2 plus cos theta d theta of 4 sin theta, 4 into sin theta cos theta minus u 4 sin theta d theta of this one 2 is 0, cos theta is minus sin theta and minus d theta of theta is 1. So ultimately here I will get 2 plus cos theta whole square. This is 4 to the 8 cos theta plus 4 cos square theta minus plus 4 sin square theta minus 1. So that is, you can say 2 plus cos theta whole square. It is 8 cos theta. If I take 4 common, cos square plus sin square 1, that is 4 minus 1. If I take the LCM now, it will be what? 2 plus cos theta whole square. It will be as it is 8 cos theta plus 4, then minus 1 into 2 plus cos theta whole square, that is 2 plus cos theta whole square. Now break it. So that is, here it is 2 plus cos theta whole square, it is 2, then it is 8 cos theta plus 4, it is a plus b whole square, minus is there, so minus, it will be 2 square 4, twice ab, that is plus 4 cos theta, but minus is there, minus 4 cos theta, then plus cos square theta, but minus is there, minus cos square theta. Let's see, plus 4 minus 4 cancel, so ultimately I got here 2 plus cos theta whole square, then 8 cos theta minus 4 cos theta, 4 cos theta, then minus cos square theta. So this side dy by d theta is there. So after that we can say here dy by d theta, it is cos theta common, 4 minus cos theta, and it is 2 plus cos theta whole square. Now see one thing, we know cos theta is always the value of cos theta, that is the range of cos theta is minus 1 to plus 1. The lowest value of cos theta is, the graph of cos theta is like this. You already got it in class 11, class 12. Highest value is plus 1 and the lowest value is minus 1. So therefore, the value of cos theta never cross this limit, minus 1 to plus 1. So whatever value, if I put here, if cos theta I put here minus 1, 2 minus 1, 1 square is positive. Then if I put here the highest value of cos theta, that is 1, 4 minus 1 will be 3, positive. This is positive, this is positive. So therefore, dy by d theta should be greater than equal to 0 when this cos theta equal to greater than equal to 0, because these are already greater than 0, because if I put any value of cos theta from minus 1 to plus 1, it is always positive, it is always positive. So therefore, we will write here dy d theta greater than equal to 0 implies this should be greater than equal to 0, because they are already positive. So if this thing is greater than 0, whole thing will be greater than 0. And if this thing equal to 0, the whole thing equal to 0. Now cos theta greater than equal to 0, you can say theta belongs to 0 to pi by 2. You can say in the graph of cos function, this is 0, it is 90 degree. 0 to 90 degree, the value of cos is what? Positive, and at 90 degree exactly 0. So therefore 0 to pi by 2, cos theta is greater than equal to 0. That is dy d theta greater than equal to 0. So therefore the given function is increasing in the given interval 0 to pi by 2, hence proved. So these are very important questions from increasing and decreasing function. Dear student, you remember it. And the concept is only you have to use the differential calculus, that is dy dx. When greater than 0 is strictly increasing, dy dx less than 0 is strictly decreasing, and when dy dx greater than equal to 0 only increasing, and dy dx less than equal to 0 only decreasing. So I hope you understand. You try to write in your copy and send it in my WhatsApp number, and if you have any doubt then please get back to me, and most probably I'll send you 2 or 3 more questions answer in PDF, and then we are going to start tangents and normal, the next topic, because the application of derivative is a very huge chapter, and from all the chapters questions are not given, because the questions are given from maximum, minimum, tangent, normal, sometime increasing, decreasing, but you have to know all the concept very clearly. The concept is main important thing here. If you understand the concept, then you can do the sum also. I hope you understand. Thank you.